Alright, today we will be dividing fractions, but before we do, the story so far. So when we add fractions together, recall that it's really difficult to add fractions if they don't have equal parts. So what we do is we use our equivalent fraction strategy to make these fractions of the same number of parts. Now to do that, we find the lowest common multiple of 4 and 9, which in this case is 36. Then we work out how to turn 9 into 36 using multiplication. That's 9 times 4, and then we just times the numerator by the same number to make an equivalent fraction. This one will be times 9, and this will be times 9. Okay, that's going to be 27 on 36 plus 20 over 36, which is 57 over 36. Now you can convert that to a mixed fraction if you want, which is 1 and 11 over 36. There's no need or no requirement to do that unless stated. Now remember, subtraction works exactly the same way as addition in that it's really hard to subtract 2 from 5 when the parts are not the same. So what we do is we work out the lowest common multiple of 6 and 3, which is 6, and this is the fraction that we need to manipulate to create an equivalent fraction. So that's going to be times 2 and times 2. That's going to be 5/6 take away 4/6, which is 1/6. Now multiplication, remember our strategy was that if we identify any mixed fractions, that we convert them straight away to improper fractions. It makes it really easy to multiply. So that's 1 5s are 5, plus 2 is 7 over 5. Then what we do is we can multiply straight away, but what we do is we actually use the technique of cancelling. So we check whether this fraction can be simplified, so we check whether that can be simplified, and it can't. Then we check whether that can be simplified, and it can't. And then we just check across here and across here to see whether there's a number that goes into both of these numbers. Now 7 and 7, definitely. We divide that by 7 and divide by that one by 7, which is 1 and 1. Now what will go into 5 that will also go into 10? Well, the answer is 5. 5 goes into itself once, and 5 goes into 10 twice. Now we're ready to multiply, and we go 2 times 1, that's just 2. 1 times 1, 1. And 2 over 1 is probably best written as 2. So you'll note there that there was no need for equivalent fractions of the same number of parts there. We can go ahead and multiply straight away. So let's get on to division, because it works very similarly to multiplication. So using your current knowledge of fractions, have a go at answering these division questions. So how many times does 2/3 go into 2/3? That's the same as saying how many times does 2 go into 2? Well, the answer is just once. Okay, we've got the same amount going into the same amount, and we can fit it into itself once. Right, this one, let's do this one next. We've got 1/3 into 2/3. So we've got 1/3. How many of those 1/3 goes into 2 of them? We're going to get it in once and twice. So the answer to this one is 2. What about 1/6 into 1/3? Well, here's 1/6. There it is there. And we want to put it into there. So it's going to go in once, that one, and again another time. So that one is 2. How many times does 1/6 go into 2/3? Well, here's 1/3. So all we do is we go once, twice, 3 times, 4 times. The answer to this is 4. All right. What about a quarter divided by a half? Okay, so what we're trying to do is put this half into this quarter here. So how many times can I get it in there? Well, a quarter divided by a half looks to be a half. Okay, that is, I can get half of this, half of the half, into a quarter. So intuitively, I say that the answer is a half. What about this one here? We want to put 1/3 this one here, into a half. So I can fit all of it. Okay, so I can fit 1/3, okay, and a half of the third. Okay, so the answer is going to be 1.5. Okay, so it's all of it, and then 1/3 of it in this spot here. So 1.5. So there is a shortcut to dividing fractions. So if you can think them through, like the previous examples, or you have a picture, then division can be done quite easily. But if you can't think them through, then can be completed by running this process here, multiplying the first fraction by the reciprocal of the second fraction. So the reciprocal is just flipping the fraction. So when you see the word reciprocal, think flip. Right, so here we want to state the reciprocals of these. So this one here, we shouldn't put an equal sign there because it's not the same as. So we're just going to write 3 on 2 is the reciprocal. This one here, we're going to write 5 on 3 is the reciprocal. Notice I can't put an equal sign because they're not equal. This one here, best to convert this to an improper fraction. So 1 times 7 is 7, 3, that's 10 on 7, and therefore the reciprocal will be 7 on 10. Okay, so example of the dividing fractions shortcut. So what we do here, the sentence says division of fractions can be completed by multiplying the first fraction by the reciprocal of the second fraction. So here's the first fraction, 2 on 5, multiplying by the reciprocal of the second fraction, which is 4 on 3. So this looks to be 8 on 15 as the answer. Okay, so division of fractions is the same as multiplying by the reciprocal of the second fraction. So some of you may have heard this in primary school. Students often say stay, change, flip, or keep, change, flip. And that's the same idea. It's the same as multiplying by the reciprocal. So first fraction stays the same. There it is there. Division sign changes to a multiplication sign. So there's that. And the second fraction flips. So there flips to that, okay, which becomes 2. And I hope some of you are wondering why or how it works. So I'm going to give you a bit of an explanation. It's a tough one for some of you to follow, but I reckon you can handle it. And I'll choose this, or what should I choose? I'll choose this one here. So the answer to this is 2. I'm going to do this using a longer method. So a half divided by a quarter. We've got a half divided by a quarter. All right, so what I'm going to do is rewrite this as a half over quarter, because that's all the division sign is. And I know this looks pretty crazy because it's a fraction over a fraction, but it's perfectly allowed. All right, and further to that, what I'm going to do is choose something to multiply by. So I'm going to multiply this. Now, I'm just noting that this is the thing that I'm trying to kind of get rid of here. So I'm just going to choose to multiply this by 4 over 1 over 4 over 1. Now you might note that this 4 over 1 over 4 over 1 is actually the same as just multiplying by 1, because it's 4 over 1 going into 4 over 1, which goes in 1 time. Now the benefit of multiplying by 4 over 1 over 4 over 1 is have a look at what happens with the denominator here. We'll have 1 times 4 and 4 times 1, which means that we just get 4 over 4, which is 1. So what happens is that and that cancel out, leaving us only with the numerator, which is a half times 4 over 1. Now, what does that bear in resemblance to this? Well, it's 1, it's the same thing, okay, because this is a statement of equivalence and this is a statement of equivalence. Have a look at what's happened. The half has stayed as a half, the division sign has changed to a multiply sign, and this fraction here has flipped. So stay, change, flip. And what we get, 1 times 4 is 4, 2 times 1 is 2, and our answer is 2, just like we saw before with the kind of just algorithmic approach in this one. So we can use that approach now on all division problems. So let's do it. So dividing by this fraction here is the same as the first fraction being multiplied by the reciprocal of the second fraction. Once we've done that, we just treat this like a standard multiplication problem. I try to simplify, and I can't. I try to cancel, and I can't. So I'll just go 25 over 24. This next one here, dividing by a fraction, is the same as the first fraction multiplied by the reciprocal of the second fraction. Now I can cancel here. Divide by 2, divide by 2, 2, 1, 2 times 3 is 6, 5 times 1, 5. Alright, what about this one here? Well, I think it's best to actually write that as 4 over 1, so that you got it as a fraction. Now we know that dividing by a fraction is the same as the first fraction multiplied by the reciprocal of the second fraction. And we can go ahead now and multiply 3 over 28. Alrighty, this one here, we've got, let's rewrite it, 24 over 1 divided by 3/4. Dividing this by 3/4 is the same as 24 multiplied, or 24 over 1 multiplied by 4 over 3. Now that goes divide by 3, divide by 3. That goes once, that goes 8 times. 8 times 4, 32 over 1, best written as 32. Now this one here, before we multiply by the reciprocal of this, best convert this to an improper fraction. 10, 12 on 5, divided by 1 5's a 5, 8 on 5. Dividing by a fraction is the same as multiplying by the reciprocal. Let's see if we can cancel. Divide by 5, divide by 5, brilliant. What will go into 8 and also 12? The highest common factor is 4. 2 times, 3 times. 3 times 1 is 3, 1 times 2 is 2. So, practice.